Hey guys, today we are going to talk about ways that we can prove that a quadrilateral is a parallelogram. Remember that a quadrilateral is a four-sided polygon, and a parallelogram is a quadrilateral in which opposite sides are parallel. Okay, so one way that you can show that a quadrilateral is a parallelogram is if you know that opposite sides are parallel. So if these two sides are parallel and these two sides are parallel, then you know you are looking at a parallelogram. But there are four other theorems that we can also use to show that a quadrilateral is a parallelogram. The first one is if both pairs of opposite sides of the quadrilateral are congruent. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So in this quadrilateral here, if segment AB is congruent to segment CD and segment BC is congruent to segment DA, then I know this is a parallelogram. So both pairs of opposite sides are congruent, therefore this is a parallelogram. Another way to prove that a quadrilateral is a parallelogram is if both pairs of opposite angles are congruent. Okay, so in this quadrilateral, if angle A is congruent to angle C and angle B is congruent to angle D, then I know ABCD is a parallelogram. If I see opposite angles are congruent, then I know that I'm looking at a parallelogram. So we have both pairs of opposite sides congruent. That makes this a parallelogram, which means opposite sides will be parallel. Both pairs of opposite angles are congruent, makes this a parallelogram, which means, once again, both pairs of opposite sides are parallel. A third way to prove a quadrilateral is a parallelogram is that if one pair of opposite sides of a quadrilateral is both parallel and congruent. So here, if side BC, segment BC is parallel to segment DA, and segment BC is congruent to segment DA, then I know this is a parallelogram. Okay, this one pair of opposite sides is both parallel and congruent. And the last way to prove that a quadrilateral is a parallelogram is if the diagonals of a quadrilateral bisect each other. So that means they cut each other in half. So that means that this point right here would be the midpoint of AC and the midpoint of segment BD. Okay? So if segment AC and segment BD bisect each other, then ABCD is a parallelogram. Now, how do I know if these two diagonals bisect each other? It's this right here. These two segments are congruent, so BD is bisected, and these two segments are congruent, so AC is also bisected. So the diagonals bisect each other. That makes this a parallelogram, which means all the properties of a parallelogram are also true. So that means that these two sides are parallel. That means these two sides are congruent. Okay, should only have one tick mark on these. Okay, so these sides are congruent, these sides are congruent. That means these opposite angles are congruent as well. All properties of a parallelogram apply to every one of these pictures. In this image, ABCD is a support for an adjustable basketball hoop. So right here, there's the support bracket for that adjustable hoop. Explain why segment AD will always be parallel to segment BC. So how do I know that this segment will always be parallel to this segment, even as the hoop moves up or down? Why will these always be parallel? Okay, so what the picture shows us is some segment lengths, and based on those segment lengths, I know that segment AD is congruent to segment BC, and I know that segment AB is congruent to segment CD. Okay, so in other words, opposite sides are congruent, and that makes this a parallelogram. Okay, so opposite sides are congruent. Therefore, okay, and I'm going to use this little symbol right here. These three dots right here in math, that means therefore. Therefore, ABCD is a parallelogram. So, opposite sides are parallel. Okay, and that means that segment AD is parallel to segment BC no matter what. No matter what angles I have here, because this will always be a parallelogram, these sides, AD and BC, will always be parallel. Okay, so here we see the headlights of a 1986 Mazda 929. Okay, and on this 929 here, you've got some headlights that are in the shape of a parallelogram. Okay, so here is a zoomed in picture of one of those headlights with some markings on it. Explain how you know that angle B is congruent to angle D. Okay, so based on these arrows, I know that segment AB is parallel to segment CD, and based on these tick marks, I also know that segment AB is congruent to segment CD. So I have one pair of opposite sides that's both parallel and congruent. Therefore, ABCD is a parallelogram. So opposite angles are congruent. And what that means to me is that angle B is congruent to angle D. In quadrilateral GHJK. And that is not drawn for us, so we'll draw it ourselves. It says that angle G is 55 degrees. This does not look like 55 degrees, so I'll call this angle G. So we'll call it angle parallelogram GHJK. Actually, all we know right now is it's a quadrilateral. Based on these measures, are we going to be able to show that it's a parallelogram? And if so, what theorem can we use? So angle G is 55 degrees. Angle H is 125 degrees. Angle J is 55 degrees. Based on that information, is there a theorem that tells us that this is indeed a parallelogram? Well, I do have these opposite angles congruent. But in order to show that it's a parallelogram, I would also need these opposite angles to be congruent. Now we know from previous lessons that in a quadrilateral, there's a total of 360 degrees on these four interior angles. So if I do 360 minus 55 minus 125 minus another 55, let's see how many degrees are left. So we have 360 minus 55 minus 125 minus 55. That leaves me with 125 degrees. And that is the measure of angle K. So we have 125 degrees here, which means these are also congruent angles. Okay? So what theorem tells us that this is a parallelogram? If opposite angles are congruent, then GHJK is a parallelogram. What theorem can we use to say that this quadrilateral is a parallelogram? So what I see here is these are congruent and these are congruent, which means the diagonals bisect each other. So the theorem I can use to show that that is a parallelogram is if the diagonals bisect each other, and this one doesn't have letters around it, so I'll just say the quadrilateral. So then the quadrilateral is a parallelogram. For what value of x is PQRS a parallelogram? Okay, so one thing we know about parallelograms is that diagonals of parallelograms bisect each other. Now these are already marked as congruent. If PQRS is going to be a parallelogram, then these also must be congruent, which means that 5x will have to be equal to 2x plus 9. If they are equal, then this is a parallelogram. If these two are not equal, then it is not a parallelogram. In fact, this would be a kite, which is something we will learn about in a future lesson. So we can subtract 2x from both sides and get 3x equals 9, and divide both sides by 3 and get x is 3. So if x is 3, then this is a parallelogram. If x is not 3, this will be a kite. For what value of x is DFGH a parallelogram? Once again, if this is a parallelogram, these will be congruent, and so will these. So 4x minus 7 will be equal to 2x. So we'll subtract 4x from both sides and get negative 7 equals negative 2x. And divide both sides by negative 2, and we get x equals 7 halves, or 3.5, or 3.5. If x is 7 halves, then this is a parallelogram. If x is anything other than 7 halves, then this is not a parallelogram. So we'll recap here. We've got 5 different ways to prove that a quadrilateral is a parallelogram. If both pairs of opposite sides are parallel, if both pairs of opposite sides are congruent, if both pairs of opposite angles are congruent, if one pair of opposite sides is both parallel and congruent, or if the diagonals bisect each other. Okay, so we want to show that this quadrilateral here, KLMN, is indeed a parallelogram. We could use the slope formula 4 times. And if we find that these two slopes are the same and these two slopes are the same, then we will have shown opposite sides are parallel. We could use the distance formula 4 times. If these two distances are the same and these two are the same, then opposite sides are congruent. so it's a parallelogram. It would be pretty difficult for this particular one to show opposite angles are congruent, so we'll bypass that one. We could use the slope formula for two sides. I'll just say these two, and if they are the same, then they are parallel, and then the distance formula for the same two sides to show that they're also congruent. Or we could do the midpoint formula for ln and then for km, and if these two diagonals have the same midpoint, then they bisect each other. Okay, so let's do option 4. So we'll use the distance formula and the slope formula. So for KL, the distance for KL, so that's x minus x squared, so we'll do 4 minus 2 squared plus y minus y, 4 minus 2 squared under a radical. Okay, so we get 4 minus 2 is 2, squared is 4. 4 minus 2 again is 2, squared is 4. So we get the square root of 8. Now that can be simplified, but for this purpose I don't need to. So let's move on to the distance for MN. X minus x, 6 minus 4 squared. And y minus y is 0 minus negative 2 squared. 6 minus 4 is 2. Put that all under a radical. 6 minus 4 is 2. Squared is 4. 0 minus negative 2 is 2. Squared is 4. So we get the square root of 8. These two are the same. Okay, so I know that these two sides are congruent. Okay, now let's use the slope formula. Slope is change in y over the change in x. So the slope, m, of segment KL, change in y, so y minus y, 4 minus 2, over the change in x, which is also 4 minus 2. And that is 2 over 2, which is 1. So the slope of segment KL is 1. Now let's do the slope of segment MN. So M for slope of segment MN. Y minus y is 0 minus negative 2. X minus x is 6 minus 4. 0 minus negative 2 is 2. 6 minus 4 is also 2. The slope is 1. They have the same slope. So these two segments are parallel. So I have shown that one pair of opposite sides is both parallel and congruent. So one pair of opposite sides is parallel and congruent. Therefore, KLMN is a parallelogram.